where does calcium come from? We look at sources of calcium. Calcium is normally found in the form of lime. Lime is basically calcium carbonate that comes from limestone. Limestone is often biologically created. It's a sedimentary type rock that you get from excessive growth of corals, seashells, and other materials like that. The calcium is not extremely soluble in that particular form. These things tend to build up. The state of Florida sits on an old coral reef, which is nothing more than limestone. Limestone is one of the sources that we use. We have dolomitic limestone that has magnesium. Magnesium is an important fact. The amount of magnesium that we need in order to be able to have proper growth is not nearly as much as calcium. When we deal with dolomitic limestone, we only need to apply it about every third application. First time you are going to put down lime in an area, you put down dolomitic limestone, then every third application you would repeat that. You do not need to put it down every time. Dolomitic limestone is often a little bit more expensive. We also have calcium sulfate, which is called gypsum. Calcium sulfate is, again, a very important type of material. Certain pollution control devices may generate gypsum. We use gypsum to make sheetrock that is often used as a material on the interior line of buildings. Calcium sulfate is very important there. There are other mineral forms of calcium that can be found in the environment. Calcium reacts with a lot of different types of materials to give you crystalline type structures. There are a lot of different materials that you might use. The limestone and the dolomitic limestone are probably the top forms that you're going to find. We apply calcium in the form of lime. We're looking at calcium oxide, calcium hydroxide, which is called slaked lime. You've got your calcium carbonate, which is your regular lime, and your magnesium carbonate as well. The way these work is they get mixed into the soil. It actually takes from 4 to 6 weeks for the reaction to occur. When you apply lime in the off season, and you may apply it in the dead of winter because it's going to take a while for it actually become incorporated in and make the reaction occur. The reaction is like this. If you take calcium carbonate, it picks up 2 hydrogens. That's going to release your calcium divalent cation and create carbonic acid, which breaks down into water and carbon dioxide. The carbon dioxide is released off. You've got the water there. What you have effectively done is you've removed hydrogen from the soil solution, which means you've changed the pH. Calcium oxide plus water gives you calcium hydroxide, which combines with the 2 hydrogens to give you the divalent calcium ion, as well as 2 waters. In either case, what you're getting here is the release of the calcium off. As you get the release of the calcium off, this is going to allow for changing the pH because it's going to remove hydrogen ions. Lime should be mixed into the soil as it only converts acid locally. If you spread the lime on the top of the soil and you don't mix it in, you could drive that top ½ centimeter of the soil up to a pH of 8 or 9 or higher, which is why you apply it, then you mix it in. When you mix it in, it allows it to convert the entire upper strata of the soil. You want to soil test every 2 to 3 years to determine the amount of lime that you would need. Soil reaction, pH. pH affects nutrient availability, it affects rooting, and it affects microorganism activity. You have to have the proper pH for all of these to occur. Microorganisms, depending on what they are, might like it a little more acidic. When you look at microorganisms, what they often do is, like a mitochondria, they take hydrogen ions, they push them to the outside, and then they can bring the hydrogen ions back in. As they do that, that gives them the energy to generate ATP through ATP synthase. If you've got a lot of hydrogen ions on the outside, organism's not going to grow as well. So with the calcium, you change the pH, it raises the pH, you got less on the outside, which means these organisms will grow a little bit better. Calcium, being a divalent cation, also causes flocculation of the soil. That itself will improve soil structure. What flocculation of the soil means is you've got 2 soil particles. Calcium will bind the 2 of them together, being the good divalent cation it is. As you do that, you get larger particles. Then calcium will grab onto that particle and another one, and the next thing you know is you get much larger particles. That causes these things to become larger. They drop out of suspension. As they drop out of suspension, it improves soil structure. Calcium is very good in there on a soil that is what you might call very loose. Now, it doesn't work too well on sandy soils, because sandy soils don't have the cation exchange capacity. Measurement of soil pH, rather simple process. What you do is you have a 1-to-1 volume soil-water mixture. The standard thing is to take 10 grams of soil and 10 milliliters of double deionized water. You're going to use the double deionized water because that's going to have a lot of hydrogens in it. It's not going to have anything else that might cause flocculation. That's going to allow the material to equilibrate in there very quickly. Let it equilibrate for 10 minutes. Then you put your pH test strip or you put your pH test meter in. As you do that, you get your soil test. You're basically looking 1-to-1. If you don't have something where you can do 10 grams of soil, remember the soil has a bulk density of 1.3. Water has bulk density of 1. What you want to do is measure it volume. You can use a little less soil, like 3/4 of a teaspoon of soil, 1 teaspoon of water, mix them together, let them sit, and then measure the pH. They sell a lot of different materials that you can use to measure pH. When we deal with calcium and calcium application, we look at lime buffer capacity. We got to know how much to put down. The soil lime buffer capacity becomes very important because what you're looking at is what is your pH? How well does your soil control pH? Remember, when we talked about cation exchange capacity, it became very evident that things like clays have a large cation exchange capacity where something like sand does not. Sand has a low soil lime buffer capacity, whereas something that has a good montmorillonite type clay or a organic matter will have a very high soil lime buffer capacity. That's basically the measurement of the amount of soil acidity that must be neutralized to raise soil pH by 1 unit. You can actually measure these. You take the weight of pure lime in milligrams needed to raise the soil pH of 1 kilogram of soil by 1 unit. That's going to give you your soil lime buffer capacity. This will be much lower in sands than it will in things like clays or organic matter. Calculation. The lime requirement, milligrams of lime per kilogram of soil, equals the lime buffer capacity times the target pH minus the initial pH minus 0.6. They often measure this at 30 minutes of less than 250. What you do is you take the lime buffer capacity at equilibrium is equal to 3.67 times lime buffer capacity at 30 minutes minus 188.25. If your soils have a lime buffer capacity of 30 minutes of greater than 250, the lime buffer capacity at equilibrium is going to be the lime buffer capacity at 30 minutes times 2.9. So they measure these at 30 minutes because if you're waiting for equilibrium, that could take several days. That's not a good measurement or something that people can deal with because everybody wants a result now. They figured out if you measure the lime buffer capacity at 30 minutes, it will give you the ability to calculate this. The lime buffer capacity at 30 minutes is the calculation of equilibrium at 30 minutes. Once you've got that, you can take your lime requirement, and that equals your lime buffer capacity times your target pH minus your initial pH times 2, right? Because your divalent cation times 1.5, and that is going to give you a value in pounds per acre, which is going to be approximately equivalent to kilograms per hectare. This also works on a 6-inch furrow slice. What a 6-inch furrow slice is when you plow the soil, if you're plowing down to 6 inches, which is often what is done, that's a 6-inch furrow slice. If you're going down to 8 inches or deeper, you would have to calculate it at a deeper depth. We often look at a 6-inch furrow slice. If you've got an 8-inch furrow slice, you multiply your answer by 8 divided by 6. And that's going to tell you what it's going to be at a little bit deeper furrow slice. All of this information came from the UGA Soil Lab. You can find that online. When we look at pH requirements, you look at where do we need the pH of the soil to be in order to be able to get these things growing. The least acid tolerant things are alfalfa, sweet clover, and barley. They like the pH up there around 7 at neutral. You've got medium acid tolerant plants, which will include things like corn and soybeans, or sorghum. The grasses tend to be a little bit more tolerant still, including oats, wheats, and rye. Tobacco is down around the same range, and these will actually go for a pH in between 5.25 and 6.75, which means if you're looking for a pH of around 6, they will do fine. If you've got buckwheat, vetch, potatoes, or blueberries, they are going to be the more acid tolerant ones. Notice the blueberries are way down at around 4.5 to 5. They like it acidic. There are other plants like azaleas. You'll find cranberries like it acidic. And potatoes are going to be down in the 5 to 6 range. It's always best to have a pH of around 6 because that will allow most things to grow fairly well. When you look at your lime requirement, the lime requirement basically comes down to what is the pH of your soil, what type of soil do you have, and how much do you need to get it to move upwards. Notice, it's got grasses versus arable things, which are your dicots. Your dicots are going to require somewhere around twice as much lime as would be required for a grassy material. You can kind of use this as a general rule. If your soil pH was 5.1 and you wanted to raise your soil pH up to, let's say, 6, you would look at the type of soil you've got. If you had a sand or loamy sand, you could basically take at 6, your requirement is 6 tons per acre. At 5.1, it would be 11. So to go from 5.1 to 6, if you added in about 5 tons per acre for a dicot crop, you'd be doing all right. If you're looking at a grass, you're going to have to add about 4 tons per acre. Now that is tons per acre. This, when we're putting lime down, it takes a lot of it. You have to look at exactly how much you're dealing with in order to be able to have these materials proper for growth of these organisms. Calcium, very interesting material. A lot of different things it does, but it's really got one function. When you're looking at putting it down, you're only going through one particular spot. That is the application of a lime-based material that is also going to influence your pH.